Hello, welcome to this series of video. I'm Mary Calancis from the University of Illinois.
And I'm Bill Cope.
Yes, lovely to have you with us again. In this next series, we are going to talk about generative AI and its impact on language learning. Of course, generative AI is having an impact on everything, and it's sometimes bewildering, much debated about its impact and what it'll do for education. But we're going to focus in these three on its particular impact on language and language learning. And we have three parts that we're going to address. The first part involves the history, a short history, a very brief history of the way in which the whole generative AI has evolved. And from our perspective, it's been absolutely mind-bending. And the second part is we're going to work out or discuss with you how you parse the meanings that are made in this context through large language models and generative AI. And finally, the third part is our suggestions about how AI can be deployed in a way that enables the future of education to maintain its values. Now, of course, all technologies have been disruptive and have created anxiety. And way back, if we go into history, Socrates himself felt that once literacy became universal, that people would stop being creative and stop memorizing things. He was very anxious about that shift from oracy to literacy. It was a deeply felt anxiety about what was coming down the line.
So one of our themes here is the way in which technologies which use language as a medium change, actually, our phrase there is changing our minds. So, these things, and look, one of our arguments is that generative AI is about to change our minds again. It's profoundly very important, and it's another textual technology. Now, the thing that Socrates was saying here was that, in fact, writing reduces the need for memory. And on the right side of the image here, we have a reference to a marvelous book by Alfred Lord, who looked at long song poems in the oral culture of the Slavic world. He did this in the 20th century when people were still remembering these long poems, and went back and reinterpreted Homer. So what he did with Homer is he said, look, what Homer's about, it's actually about something which wasn't initially written, the stories of Odysseus and all the rest. And the way in which something that long was remembered was via rhyming schemes, via repetition. And these are actually a whole set of cognitive skills which Socrates was right about, which actually did change human capacity to remember. Now, one of our themes here is that we now have writing as a kind of a cognitive prosthesis. You go and write things down in a list so you can remember things, or you write things down to think things through. So it extends what's possible in terms of human capacity, but also reduces some other things. It's very likely that's going to be happening with AI now as well, which is the reason why we mention this here.
Right. So it shifted oracy into literacy. And Walter Ong in about the 1980s or 1982, who was a Jesuit priest, an American Jesuit priest, wrote extensively about the differences between the elements of oracy and the elements of literacy in meaning making.
Back in 1982, Walter Ong wrote this very important book, Orality and Literacy. Before that, perhaps his most significant book, a long and obscure book, which he's got there sitting in front of him, is about Petrus Ramus, who was the inventor of the textbook. And what he argued was modern education comes to be shaped by the printed word in the printed textbook, and it changes the form of meaning. So back in Socrates' day, who we were just talking about, knowledge and understanding was dialogical. What happened with the coming of the textbook was the rearrangement of knowledge in this very fixed way, and didactic pedagogies and a whole lot of things that came with it, with the arrival of the textbook. What Petrus Ramus was professor at the University of Paris in the 16th century and became a prolific textbook writer, 1,000 odd editions in that early modern period. So this is Walter Ong, and then he came to think very much about this these sort of contrasts between orality and literacy. So this slide here is a pile of words, and you know, we've read the orality and literacy several times, and our kind of declaration, our full disclosure is this was a ChatGPT summary of what he says in the contrast between orality and literacy. So, you know, there are a few kind of key ideas in here that what you have, and he didn't quite say it this way, I'm going to say it this way. What you have in orality is a world where there are a lot of implicit shared meanings. We're in the same time, we're in the same space. But what happens with the coming of literacy is a whole other way of representing the world, because the people who are the receivers of literate texts are not there with you in the same time, in the same space. So, you know, one of the things is that it changes the nature of thinking in a whole lot of ways, this literate world. And in fact, what he's talking about are these epistemological differences. Now, the really important point in the third column is Walter Ong has this concept of secondary orality, which is where we come then to have our oral culture very much influenced by literate culture. So a lot of what I'm saying now is not quite the way I would say it if I was talking to you in a cafe or something. That what we've done is we've kind of learnt these literate ways of representing the world, which are, and look, you know, there you are on a video. I'm having to be quite explicit about things, but we're not in the same space. We're not sharing the same time. So in other words, what happens with secondary orality is the changing of orality itself influenced by literacy. So this is, you know, again, the important point we're making is the way in which these technologies of language and text change our ways of being in the world, but also our ways of thinking.
Right. Yeah. Now we need to take a step back and have a look at the big picture. If you look at the whole of human experience on this planet Earth, for the majority of time, oracy and multimodality dominated. People made meaning in complex, various ways with their bodies, with marks on the ground, with smoke, with works on walls, for most of human history. And then we get to a point when the literacy becomes formalized and generalized for everybody with the coming of the printing press. And you get the development of formal education systems, the university system and the school system. The university system, about 1,000 years, the school system, about 140 or so years. But for our generation and for our people, these have become the gold standards of where you go for meaning making, its production, its circulation, its consuming. And essentially they're based on what the printing press produces. And the printing press, of course, was controlled by particular powers, who gets published, what gets published, who's left out. All of that comes with the printing press as you get a more homogenized view of meaning making depending on the context and the culture in which you were operating. And there were, of course, benefits to this because the society, the industrialized society of the time, needed people to be able to understand commands, follow orders, behave in certain ways. And the text, the written text, became key to the way in which industrial societies operated. And then we moved more recently into what we were calling just a few years ago the digital age, where multimodality returns and you can make meaning with sound and music and visuals and text easily. Even little children can go to a device or a computer and make meanings, produce meanings, circulate meanings, engage with different modes and mix up the modes as well. And we thought we kind of got a handle on it, and we were moving towards online learning, which was sort of taking that out, the textbook culture and the book culture into the online environment and adding human engagement with it. But right now, and very suddenly, we've had this explosion, which we call AI, generative AI, the development of large language models, which in fact we have a different kind of control here now. There's half a dozen men in America, 4 men in China, 1 in France, who have scraped, and one could say stolen, all that humans have produced and created these large language models, which now they sell back to us. And in a sense, we're kind of hostage to it because it's become so ubiquitous a tool and a capacity that avoiding it, ignoring it, not using it is kind of no longer an option because it has so many forms. But I want to emphasize that these things did not come out of the academy. Of course, it was people with degrees from our academies that produced these large language models, but their motivation and their purposes were not educational in the way that we understand education within the formal education system. And they're circulating in powerful ways, changing all the time, even as we speak and we think we've got a handle on it, they continue to change all the time. But we're going to focus on the language component of the large language models and try to understand what that means, how you parse its meaning, and how you might deploy it despite the enormous challenges and more anxious making possibilities that it presents. So if we take that one moment, that a very important moment within industrialization, when meaning was able to be mechanically reproduced, the text, it started in China, of course, but then Gutenberg expanded it in Germany and across the world. But all meanings were controlled, they were designed, but then they were reproduced and circulating, whether it was the Bible or the dictionary or textbooks or novels or whatever, they could be reproduced. They had an initial author under controlled circumstances, but their distribution and take-up was as a consequence of mechanical reproduction. What we have now, though, is not mechanical reproduction. We actually have mechanical production. This image now was created by a prompt that Bill actually put into the computer, saying what he wanted. It looks like it's a religious image, but it also has other factors in it. It was produced by the large language model on the basis of the prompt that Bill fed into it. Now, this is the first time that meaning making can be produced in this way and circulating in this way. We'll say more about it as we go on, because all of it is human. Humans created these large language models, humans fine-tune it, humans design the algorithm, humans put in the prompts, and it produces extraordinary outcomes. And it can also be fine-tuned to give an account of how it came up with this picture or with any particular test. So this is a really different moment than the moment of industrialization that introduced the printing press and those things that we still think are the gold standard for creativity and meaning making, and in particular for use within educational contexts.
So how do we understand these machines that, if you like, make meanings? And we've got a very simple model here that we're going to elaborate upon in the rest of this video. So, there's meaningful stuff that we're putting into the machine. We're typing it in, or it's recording what we're doing, and it goes through a process of what we call transposition, and something comes out that's meaningful. Now, in the middle of that process in modern computing, everything has to be written in binary notation. So it's a writing machine. Computers only calculate because they've got numbers that have been written, which are zeros and ones, but every word is turned into zeros and ones. And with that transposition process, mediating it through binary notation, we have graphemes, which is the letters of the alphabet, for example. We have pixels, which is all the arrangement of the images. So, you go across an image and top left-hand corner is pixel number 1, and it's got color number blah, 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 blah. So everything's numbered and named via numbering. That's what pixels are, whether it's a character or whether it's an image. And then also elements of sound as well. So everything is reduced to binary notation. So what we're going to do from here is talk about the 3 ages of AI. So how does AI, if this is fundamentally underneath what the machine is, well, okay, what's AI in this process of manipulating binary notation, of using this writing form, if you like, the machine, the mechanized writing form that the computer is.
And the 3 phases are, we believe, very distinct to this point. Who knows if there's another phase coming, but so far we've had a symbolic phase and we've had a data-driven phase, and now we're working with something that we call text semantic phase.
And look, the point we want to make, and just by way of introduction, before we actually get into unpacking each one of them, they are profoundly different approaches. So people say AI, AI, AI. Well, in fact, these are almost 3 very different technologies. Very interesting thing, by the way, the latest AI, the most sophisticated versions, actually use bits of all of these models in order to do different things within the AI environment. But the underlying mechanisms are very, very different, and we're going to try and unpack those now.
And I think also as we move towards humanoid robots, another phase is probably evolving where multimodality becomes more important and the context becomes more important rather than, the bag of words that the AI sometimes is attributed as being.
Okay, we will start with the first generation.
Mm-hmm.
And look, in a way, the first generation begins with the first computers because what that is they're symbolic systems, in a sense, programmed expert systems. And we're going to give the example here of the first educational application. So, in fact, in some definitions, the first AI was probably the machine that Alan Turing created in Manchester in 1945, just after the war. But the example we're going to give here is the first application of that paradigm, that type of computing to education, which is Plato, created here at the University of Illinois. It's not Plato the philosopher. It stands for programmed learning something. It's in dispute what it actually stands for. So anyhow, and there is a kind of a relatively late version of it. They began building it in 1959. It's a great story and well worth reading. Mary and I have written this article, which we've referenced there on the bottom of the screen. So this was the first programming of learning, if you like, with one of these symbolic AI environments. Now, some people would dispute whether this is AI, and our definition is partly that all computer programming is a kind of AI. So here's an example. This is actually from the early 1960s, a kind of a flow diagram about how things work. And I'm going to kind of give you an example of how Plato worked in language teaching and learning. So what you might do is that you might put in a text. Let's say it's a comprehension. And then you ask a question underneath. And the question is, what's happening in the text? And the student gives an answer, which is right or wrong. If it's wrong, something happens. Maybe another question. Maybe you do something different. If it's right, you get a mark for it, and so on. So this is a kind of a way of mechanizing the relationship of learners to understanding text in this kind of model here. As I say, this is one of the original
Like
flow
a
diagrams.
tutoring, they call a tutoring system.
Later on, they came to call exactly this logic intelligent tutoring systems.
Mm-hmm.
So intelligent tutoring systems, which are often very sophisticated, are built on this first generation programming logic, which is still of great value in some places, I might say. Mm-hmm. So anyhow, the important thing here was that in fact the machine is governing the relationship with the learner and collecting more data and being more responsive than a teacher could ever be. So let's say I get the answer wrong, Mary gets it right, she can go on and do something else, but I might have to get another question until I get it right. So what it does, it kind of mechanizes that relationship. But the most important thing is it's an expert system which has a theory of comprehension, if that's what the learner's doing, and builds a set of small steps in a sequence which are programmed. And in fact, literally, this system was called programmed learning. Yeah. So it was A, a software program, but B, it was programmed learning. So this is by the way, software development still is this logic.
Yes.
Any software program has a logic along these
Yes,
lines.
and it learns from the learner the data,
Right.
and
Right.
it reutilizes or recalibrates that data in order to keep the learner progressing through a particular sequence of goals.
And what's artificial about it? Artificial about it is it's the machine that's doing things that humans would do, but also it can do it quicker and it can do it more comprehensively and deal with much more data. You know, a teacher,
Given the algorithm.
given the programming logic and the algorithms that are written in the programming logic. So in a way, what we're trying to do here is characterize this as a whole paradigm. It's software development at one level, but another level, look at the words in those boxes. Another level, it's a set of procedural instructions ordered systematically in text, and in fact, that's all software is. So software.
Pedagogically, it was back to didactic.
Well, pedagogically, when it was implemented, it was programmed learning in the
Yeah.
sense that in the behaviourist sense, which
Yes.
is I've got to get the answer right or wrong, and that's the only alternative.
Right.
So yes, it was that, but what we're trying to portray here is a certain kind of mechanical logics for dealing with language, which language is the procedure. And in this particular case, if the text is comprehension, it might be the curriculum as well. Now, one thing we do want to mention at this point is one very interesting example of these programmed expert symbolic systems is the chatbot. And interestingly, we have chatbots today, but they're not what the chatbot originally was. So here we are back in 1966. Professor Weisbaum at the university at MIT created the world's first chatbot. And you can see here there are general questions, and you, which is the person being asked, gives a specific answer. And then there's another general question, and you give a specific answer. But in fact, a kind of a tree diagram had been created, which had a sequence of questions. And if you answer one way, another question, answer another way. So in a sense, this was an expert programmed system. What's very interesting now is the chatbot has been leveraged in a very different way, but with the same underlying logic, by the way, in generative AI. And this is a process called inference. So we're going to get to this in a second.
Much more content in it.
Yeah, there's a huge amount of content, and what happens is it has a big knowledge of the world, but it's only what you tell the machine. So you put the prompt is a pile of words, and it infers an answer to that, and then gives you the answer. So it's a kind of a dialogical process. Now, interestingly,
less mechanical than this.
This was very mechanical.
Yes.
But what was interesting, what was clever about it actually, there's a kind of a not very funny story actually, which was that Weisbaum's secretary, which in those days the professor was a man and the secretary was a woman, was interacting with Eliza, and it was asking all these questions. And by the way, his questions were based on Rogerian psychology, which is, what the psychologist does in Rogerian psychology is they ask questions and don't say much. Oh, another question, another question, another question, and it leaves the person being analysed. It gives them. They sort the problem out for themselves just because they're being asked these questions along the way. So that's what it was based on. And interestingly, that's also psychologically why we kind of love generative AI today, because it's based on the same kind of logic. Anyhow, getting back to the secretary was given this thing to do on, Rogerian psychology, questions like these ones here on the screen. And after a while, she said to the professor, "Do you mind leaving the room?" Because the next answer was going to be relatively revealing or embarrassing or something. So it's interesting that kind of the psychological lure in chatbots was there from day one. The only point we want to make is that the same logic's there now, but with AI inference, it's kind of just much more sophisticated. It's not a mechanical series of steps in quite the same way. Now, we're going to move now on to Generation 2, which is very, very different. And what we have in Generation 2 is this notion of machine learning, right? And there are two forms of machine learning. One which is supervised machine learning. So what happens is that I have a whole pile of data and I group things in that data. I'm going to give you some examples in a moment around writing and learning. We'll get to that in a second. I group them and I give them labels. I label them, right? These things, I'm going to label them this. These things, I'm going to label them something else. So here's an example of classification, actually. That's what it is. I've got data and I classify it. So let's say I've got a text, and there's a mention of things that are good and mention of things that are bad, and then I label all the good things. That's good. That's good. That's bad. That's bad. This is indifferent. And then when the machine finds these things again, it's going to reapply those labels. But what clustering does, which is unsupervised learning, is the machine notices patterns and asks the user to put a label on it. So, and what this depends on, this kind of system, it depends on huge amounts of data, a lot of labeling, a lot of human labeling, but then there's the pattern recognition produces generalizations when new data is introduced, and that then allows the machine, on the basis of that machine learning, to interpret what the new data is without human intervention.
Now, a very, very important point that we want to make here is that we, every human, whether we know it or not, if we're wearing a watch or using a device to phone up or a computer, has become content for the AI because it collects our data. It's these uses that we have are learning components of the AI, evolution. We can. It's very hard to escape it now. And what it does is, privacy kind of melts into air, if you want to put it that way. The learning component of the AI and the large learning models depends on our usage across a number of devices and a number of activities, and it's thirsty and hungry for content. And we keep producing that content by participating in the use of artificial intelligence, whether it's in our cars, our phones, our booking theatre, texting with our friends, taking pictures. So it's an extraordinary phenomenon at the moment, and I used this word earlier. We're kind of hostage to it if we live and work within this space now that's made AI and generative AI and the large learning models ubiquitous in our lives across all domains.
So Mary's using the large learning model. This is not large language models. We haven't got to that yet. This is learning that's everywhere, but it's data-based, not language-based. Now, let me try to explain that. When I go and purchase something on Amazon, I give that purchase a validity because I'm one of many people that have purchased it. So that data becomes part of the popularity of that particular product. When I put a 5-star rating underneath, I'm actually giving information as well.
Right.
So in all these environments, we're always giving information. Now this is paradigm 2. It's not paradigm 3. It's simply huge amounts of data where we're giving information about ourselves, silently, sometimes explicitly when I give something a star rating, but sometimes just simply, look, the TikTok algorithm is an amazing example of that, where just simply the number of seconds you spent on a video becomes data about you, which then feeds back into how much money the influencer gets, but also feeds back into what you're going to go get next. Now, these are learning systems, and in terms of the history of the internet, people, you might have heard this expression, Web 1.0, Web 2.0. Web 1.0 was just simply putting information out there, right? Of which Wikipedia might be an early and good example. Web 2.0 was social media, where I can have my own page, on Facebook or whatever, and I can then like other people's work. So it's highly distributed social media. But in a sense, this is another model which layers over both those models, of course, by the way. This is another model entirely where what we have in these digital media systems is learning systems all the time, learning about you, learning from users, and using that information for all sorts of purposes, like advertising and profiling and things like that. So the fact that these are learning systems becomes important. But this is a distinctive feature of Generation 2. Not Generation 1, and Generation 3 is a completely new kind of paradigm. But nevertheless, these are pervasive, they're everywhere, and they're important.
But now all sorts of agents know who we are and how we are, what we're thinking,
right,
what we're doing, what our actions are, and can be used for all sorts of positive and negative reasons at the moment. I mean, talk about surveillance, subtle surveillance,
Right.
continuous subtle surveillance that is occurring everywhere. And the important part of it is that it's unregulated. There's a lot of debate about whether AI should be regulated. In some countries, there is a kind of a demand that it's regulated in relation to what's taken from children, for instance. But in other countries that want to keep exploiting the ways in which AI can become commercialized, they want to keep it completely unregulated. And so the degree to which we are, as I said before, hostages to those people who control the AI and shape it through their fine-tuning and shape it through the
also,
way
this
they
is
operate.
This is about data. And the best example is Google.
We are the data.
We are the data. That's right.
Yes.
We're the product, right? So, Google, for example, knows so much about you. It's got your emails if you're using Gmail. It's got all your navigation that you do if you're using Chrome. It's got huge amounts of data about you, and that it then sells it as advertising data. There are a couple of points in this list, though, where the third generation comes in. The very last point there is about generative AI, which can learn from your prompt history. So it's learning from you as you use it. The other ones are mostly not generative AI, although what's interesting is generative is coming to be part of these as well. But really what we're trying to characterize here is paradigms.
And the data.
And so this is the big data paradigm, essentially. So what we want to do now is talk about these in relation to language, right, specifically. So what happened in generation 1 was an attempt to understand the logic of language grammar and basic structures of language and see if that could be turned into an expert system for machine translation. That's really what it was for back then. And it broke. Basically, it didn't work. There are a whole lot of reasons why these reached their limits. And this person in this image here is Robert Mercer, who actually got his PhD from here at the University of Illinois. And after he went to work at IBM. And at IBM, they developed a thing where they were, look, let's not worry about what's in language. Let's just look at all the words there are in language and work out statistically their relationships. And this became a fundamental paradigm shift. And there's a story which gets repeated often, which has got some truth in it, I think, where his boss said to him at IBM when they were doing this kind of machine translation, language processing work, he said, whenever we fire a linguist, the system gets better. We don't need to know anything about language to be able to count what's happening in language and then draw generalizations from those statistical inferences.
Yes, but those generalizations were very particular. They were ideological, they were political, they were social. They were looking for ways to influence through the combinations.
In his story, and I've got to finish the story. Yes. So here's a story about how these things can be political and ideological. They're not necessarily that. It's just numbers and stats, but how they can be used in this way.
Well, it's the purposes. It's how people use.
Right, they can be used for all sorts of. And by the way, he made his billions by using these processes to track stock market trades. That's right. And news about the company, company news and whatever. He used these techniques
as a well-trained graduate from our university.
As a well-trained graduate, and made billions as a derivatives person, right? But anyhow, when it came to the 2016 election, and there was a scandal about this, and people, if you're interested in the scandal, it's worth going and looking up. He became involved with Cambridge Analytica, and the scandal was this natural language processing company had taken huge amounts of Facebook data, which is personal data, and then fashioned political advertising around that data, which had some influence, for certain, must have had some influence on that very close election back in 2016. So, it's kind of...
And it says that he also had, Cambridge Analytica also had that same effect in the United Kingdom during Brexit, the debates around Brexit.
The referendum.
Because once you get to know everybody, you know what to pitch to them. You know what to pitch to their fears, to their aspirations. And since we're all in receiving feeds and news in alternative ways, not through broadcasting, but this microcasting on our hands and phones, they discovered that this was a powerful way to change people's minds, support people's thinking, very powerfully, you could say manipulative, in producing certain outcomes. And you could do this with the economy, you could do it with politics, you could do it with social events. And it was a very powerful moment, the kind of impact that this statistical language processing had on the world and is continuing to have.
And look, it's big data. It's big data,
Yeah.
big language data. So what happened was during both those events, Brexit and the 2016 election, they were knowing they were putting out tens of thousands of slightly different ads targeted exactly to whatever your point of vulnerability or enthusiasm or whatever was. So this is at one level the possibility for psychological manipulation. The reason why we're putting it here though is it's an example of statistical language processing, big data in paradigm 2. It's not paradigm 3.
Right.
So one of the key ideas in statistical language processing is this notion of a bag of words. So there you've got a paragraph on the left. We've got literally a bag where a whole lot of words have been thrown in, and there's 1 of this and 2 of this and 6 of that and 7 of something else, which is the beginning of an analysis which looks statistically at the relationship between those words.
Now, the bag of words is an interesting concept. It's not just words anymore, though, as it's moving towards the capacity to use those words to create images and sound and multimodality. But initially, it was kind of characterized as a bag of words that could be shaped by the kind of fine-tuning and the algorithms that the owners of the bag of words, who had scraped these bag of words from the world, thought fit to do.
So now to give a writing example. So we're talking to language teachers, talking about language teaching and learning. To give you an example now of Generation 2 natural language processing. Automated writing assessment's a very good example of this. So again, this involves supervised machine learning. So the supervised machine learning is simply this. You put in 3 or 4 or 500 essays. It needs to be a reasonable number.
Right.
And what you get is a group of expert raters to give them an A or B or C or a D or a level 1, 2, 3 or 4, relatively simple levels. And then what the machine will do is simply by a statistical analysis of the words, give the next essay that comes in a grade. So this became, and look, the interesting thing is that human raters are relatively unreliable, and this ended up being no less unreliable, if you like, than human raters. So with human raters, you've got to put a lot of work into what's called moderation. So, Mary thought this Shakespeare essay was pretty good. I thought it was fantastic. So you've got to have these discussions about what pretty good and fantastic means. Fantastic is a 4, pretty good's a 3. So what happened was supervised machine learning means you train the machine to see a 3 or a 4. All it sees is words which it's put into a bag, which are meaningless. And one of the funny things about this is they would never tell you actually what it was seeing. And what ended up being one of the most powerful indicators of a good essay was it was longer, because all the machine was doing was counting the words. It was looking at what words there were, which is some of them have more syllables, some of them have fewer, but it wasn't even told that more syllables and fewer syllables in a word was a marker of good, of better work. All it had done, it had seen, because someone had called that a 4, that a human thought that was a 4, and therefore the next one that comes in that happened to have big words in it, and these, a broader range of vocabulary, it would give it a 4 as well. So what had happened was the machine never knew what it was doing around language. It was only looking for pattern similarity across things that have been labelled by humans, but what the patterns ended up being were things which you don't want to really be measuring things by. Yeah. So, you could write a rubbish essay with big words and make sure you write a lot of them and you get a great mark. So, these were, but on the other hand, look, I don't want to dismiss it entirely. What was really effective about it was, it ended up being as reliable as human raters.
Right. So longer still remains a measure of better. as long as it's not too long.
Well, the machine didn't even have a concept of long. It just saw that it was similar to something that was good, and what was good happened to be longer. Then something big happens, and we're really going to deal with this in detail in the next video. We're coming to the end of this first video in the series, but it's an absolute paradigm shift. And look, it can be tracked back to these 8 people at Google who published this article in 2017 on what's called the generalized pre-trained transformer, large language model chatbots. And in fact, it's one article there which was published in Archive back in 2017. That's the first reporting of it. And also it's the core mechanism, which is called the transformer mechanism, is about 200 lines of code. It's a tiny, it's a little idea, but a very good idea, which does something with language which machines had never done before. So we're going to parse that in the next video.
But the idea of language is different now too. I mean, traditionally we thought of a language as a vocabulary, elements of grammar, etc. But here the underlying basis is Unicode, and every single language in the whole world that's included in the basis for which decisions are made in this space.
Okay, tune into the next video and we'll go into that in lots of detail.